So our next speaker comes all the way from Utah, where he runs the engineering team at SaltStack. And he is here to give us an introduction to an event-driven approach for systems management. So please welcome Mike Place.
How about now? All right. Okay. Hi, everyone. My name is Mike Place. As mentioned, I come from Salt Lake City, Utah, and I'm very, very pleased to be here. Thank you so much to the organizers and to the sponsors. I was really thinking that during the party tonight, we should sneak in the back and put the Red Hat booth inside the IBM booth. If you don't know why that's funny, read the New York Times business section this morning. At any rate, I am the Director of Engineering and the Principal Project Maintainer of SaltStack. I also come from the land before time, from the wonderful days of BBSs when if they were out of phone lines, there was no interneting for you that day. Or from the wonderful world of Usenet, where if you wanted to argue with somebody, you had to wait sometimes hours to get a response until the Usenet server crashed and what have you. Today, I want to talk about a principle that I think is really, really interesting and that we at SaltStack have been doing a lot of work on lately, called event-driven infrastructure. But before I begin, everywhere I go in the world to speak, I always take a moment to show this slide and to give some thanks to the people who came before us. Too often, I believe, we spend time talking about what's new and what's innovative, and we praise people who are pushing the limits, but we forget to thank the people who came before us. So for those of you who don't know, that's Luke from Puppet, that's Adam Jacob from Chef, and how could we forget our friend Mark Burgess from right here in Oslo, who created CF Engine and showed us the way toward automation so many years ago. And if you don't take anything else from my talk today, I hope that the one thing that you take is that you should read every book that Mark Burgess has ever written, because they are all amazing and fantastic. So thank you so much to these gentlemen. In infrastructure today, we have a lot of data moving around. And one of the places that I want to start in this discussion is in the notion that there is an atomic unit that exists right now in modern infrastructure. And that unit of data, I believe we can call an event. So what is an event? An event is a change of state somewhere in a system that has some type of meaning and has some type of context. And so for meaning, what I mean is that an event is something that happens that we care about. For example, we probably don't care when a register changes state inside a CPU, but we probably do care if a disk array fails somewhere in our data center. The context, of course, if that disk array fails, which disk array is it? What is it connected to? What impact might that have? So there are a number of event examples that I can think of that are things that happen, again, during our day-to-day work in operating our systems. So things like hardware failures, or things all the way up on the application level, like a database record being updated. It might be code being deployed from your CI/CD system. It might be a container that is being started or stopped. It might be a queue somewhere in a message bus that's full. It might be a machine that has exceeded some measure of load, or an application, or exceptions being raised, or a serverless function executed. On and on and on and on and on, we have all of these events. And the interesting thing is, once you start to look at these events and you start to categorize them, they start to break down into silos that we're more and more used to, right? For example, hardware failure and a container started might be events that happen in the infrastructure. A DB record being updated is an event that happens inside the application, or of course, code deployment out of a CI/CD system might be a deployment event. And the point that I'm trying to make is that we're often used to thinking about these events in a siloed way, as they become associated with the tooling that operates underneath them. And the change in thinking that I hope that I can start to get us on the path toward today is the notion that these events don't necessarily need to be siloed, and that we can create more dynamic, more automated systems if we stop thinking about events in that way. Now, one thing that I think is really interesting is the question of what is the difference between a senior engineer and a junior engineer? Or what is the difference between a high-performing team in an organization and a low-performing team? One way to distinguish between the two, I want to argue, is that more junior folks and low-performing teams tend to think about problems in terms of tooling, right? They say, oh, okay, well, we're going to talk about Jenkins versus BuildBot, for example. Or in the config management automation space, they'll say, we're going to talk about Chef versus Puppet versus Salt. But I think that high-performing teams and high-performing individuals, instead of talking about tooling, talk about patterns underneath them. I think that it would be a really nice exercise in operations teams if during the debates about what strategy to undertake, they frankly just banned tooling until the end of the discussion and started instead to form the debate around patterns. So and one of the things I've been obsessed with lately is what infrastructure design patterns would look like. And this is starting to become more of a conversation. There's a wonderful book released this summer on distributed systems design patterns. If you haven't read it, I really recommend it. But I like thinking about what design patterns exist in infrastructure outside of specific tooling. So let's go through a couple of examples. The first might be logging, right? We have a really simple design pattern that has been around forever, right, in which services or processes that run on a system write out directly to log files, right? And kernel ring buffer might write out to var log messages or what have you. And then we move to a different pattern in logging that you might call a local log aggregator, right? Where service A, service B, service C, instead of writing directly to these files, write to an aggregator, right? And the kernel continues on. And then we might think about, okay, well, what does a distributed log aggregator look like? Okay, well, now we start breaking these apart by machines, and we have our individual aggregators that are there, but they all feed into a distributed aggregator, that might be backed by a database or what have you. If you look at the pattern, then you can look upwards and start to see the tooling, right, that is actually representative of this pattern. So this would be stuff like Logstash, for example. Let's now look at a second set of patterns, the patterns that might exist in systems monitoring, right? We have a really traditional kind of active monitoring pattern that you see everywhere, where you have a monitor and you configure it and you say, okay, I want to look at this service and this service and this service, and I want to check this to see whether or not this port is serving responses, so on and so forth. And if it's not, then I, as the monitor, will be configured to do a couple of things, like notify a human or send a page out or what have you. And we might call this the active monitoring pattern. Additionally, we might have what you might call the instrumentation pattern, where we have a series of machines and we have gauges and metrics on those machines, right? Or some measure of telemetry, and we push those up to a metrics aggregator. On top of the metrics aggregator, we build a metrics analyzer that looks at that collected data, figures out what it means, and after figuring out what it means, turns that data into pretty graphs that we can look at. One thing that I think is important is that there's been an extension to this pattern in recent months and years that I think we can call the correlation and query pattern, wherein we have this traditional metrics gathering pattern, but to the side of the metrics analyzer, we've begun to add another layer. And that layer consists potentially of a correlation engine. If you look at, for example, Charity's work at Honeycomb.io, she's a big believer in this notion, as am I, which is this idea that as these systems become more and more complex, as these distributed systems grow in scope and scale, it's going to become more and more difficult to test the viability of these systems through traditional means. And that in order to understand the state of the system at any given point during its operation, we're going to have to collect and correlate events. And that's how we can effectively both monitor these systems and figure out what went wrong when it does, and figure out where the bugs are. People call that debugging in production, which I think is going to become more and more relevant. Additionally, in that metrics analyzer layer, we started to build out query languages, right? You see this expressed through tools like Splunk, for example. In addition to that, we're building out like ML patterns as a part of this query language so that we can automate this type of correlation. So now let's look at pattern set 3, automation and configuration management. This is pretty straightforward. Effectively, we have a controller, and we have a set of machines which are under control. Now, most of the time, you hear people talk about this as infrastructure as code, which I think is a very bad name for this, right? Because let's think about how automation actually operates today and what it is that automation is operating upon. What we have right now is not really automation as code. What we have is automation as data, right? Because when you use most of these automation or configuration management systems right now, you express the intended state of a machine in terms of a data structure, which might represent services or might represent files to be laid down or what have you. And then what we do, unfortunately, I think, when we consider what automation is in today's world, effectively, it's these data structures which represent intended states, which are then pushed out to machines by humans when we want to change the state. Well, that's cool. Like, I like that, right? And that's how I make my living, and I think that's neat. But I'm not really convinced it's the best we can do when it comes to automation. I believe that automation can be a first-class citizen in the life cycle of an application and the life cycle of a machine. What do I mean by first-class citizen? I mean, so often right now when we think about automation and configuration management, what we're really talking about is the first 30 seconds of any machine's life, right? We're talking about representing the state that is the delta between some machine image somewhere, right, and how the machine is supposed to operate in production. And we can apply and reapply and reapply that state because, as Mark Burgess would tell us, there's chaos in the universe and sometimes things go horribly wrong, and we need to keep these devices in line. But I think using an event-based approach, which we'll get to in a second, we can extend that model so that automation is something that is being applied as the entire system changes shape, as load differs, as machines fail, on and on and on and on. So, as I said, the state of automation today is focused primarily on deployment. I think it's unfortunately built without performance in mind. Performance has to be a first-class citizen when we're thinking about automation if we're going to move from this notion of being concerned primarily about deployment time to automation that actually runs moment to moment to moment, what I would call more real-time automation. As I mentioned, it's built around state representation, not around real-time integration. And the last thing to say about automation today is that it's reached the point where this states as data model is getting really, really hard to reason about. It's really nice when you're looking at a set of services and you say, okay, we can represent this in YAML or some set of data structures or Puppet's DSL or what have you. That doesn't really scale when you start to have thousands and thousands and thousands of lines about this stuff, and it's a problem we're going to have to consider. Now, I think one way that we can get around this is what I call event-driven infrastructure patterns, all right? So I've been thinking a lot about how to come up with a definition for this, and this is the one I came up with last night. So my one next week might change, we'll see. But event-driven infrastructure interconnects logging and monitoring and telemetry with configuration management and automation to instantly react to changes in state in order to create systems that are elastic and resilient and scalable. So what kind of features do we have when we talk about this? Because that's a very grand notion. So what we say is that meaningful state changes in machines and applications and business processes, all right, can consist of structured data, which we can call an event, okay? So get that in your head, and then go, okay, events can be streamed to consumers, right? To anybody who is interested in this stream of state changes being emitted from machines. And consumers then can react to these changes in state by executing actions triggered by events that match their interest. So one interesting thing about this is that we know how this model works because we've been doing it in software development for years and years and years. Anybody in here who's ever written an iPhone application, or quite frankly a GUI of any kind, knows any JavaScript programmer knows all about this model, right? This is essentially, right, an event loop model with callbacks, but being applied to infrastructure management. I call this notion reactivity, right? A reactor is a service which can ingest this stream of events, and it contains a set of rules which evaluate those events and determine relevance. And then reactions are things that happen when an event series triggers a response, right? Because we know about this pattern, right? In the GUI programming model, we just have these set of functions which handle events, and we bind the registered functions to these events, and then we have this event loop that goes on and on and on and on, right? Like Node.js is another really nice example of how this operates. So if you were to structure a data structure around this event-based idea, here's how it might look, all right? We might say, okay, all of our events have a tag, right? And if we match that tag, which here would be /client/load, here are a set of reactions. Here are some things to do when we receive an event like that. We might react by printing the event out. We might add this event to a register so that we can know, okay, if we receive X number of events in Y number of seconds, there are some things to do. And we might apply a set of rules, all right? We might fire additional events, so on and so on and so on. So event-driven infrastructure uses these same principles as event-driven programming and reapplies those to infrastructure management. So let's actually look at some event-driven patterns and see how this would work. So returning to our original distributed logging example, you can see here we've added simply two pieces. First, in our distributed aggregator, we've added a reactor, right? This reactor is listening to these stream of events, in this case, a stream of log messages coming in from machines. It's applying sets of rules, and then if one of those rules matches, it's calling out to an automation engine to actually change the state of the system. The automation is doing the heavy lifting in response to what's actually happening in the system. That's what automation should look like. Here's instrumentation with a reactor, okay? So we have the same idea, right? We're ingesting, this stream of telemetry data that, right now at present, we're effectively just graphing against for the most part so that we can look at pretty graphs in our network operations center, what have you. But event-driven infrastructure would have you ask the question, well, what happens if we insert a reactor into this, right? Such that if we exceed some threshold, a reaction can be executed and the automation engine, again, can change the state of the system in response to that. So in my view, there are some advantages to this pattern. One is this is distributed and it's scalable, but most importantly, it's loosely coupled. Because right now, this monolith of configuration is really, really hard to reason about. Try being a new employee coming onto a team and being thrown, 10,000 lines of Puppet code or 10,000 lines of Salt code or what have you. It's going to take a while to reason about that. We started out, when we started on this idea of DevOps, right? The reason that DevOps was successful initially was because we took these two teams and we said, we can build a linguistic bridge between these teams, right? We can build this shared language so that the dev folks can go, oh, okay, right? I can speak this language, and the ops folks go, okay, I can speak this language, and then the language operates downward onto the infrastructure itself. Well, the language is becoming so complex, right, that we're undercutting the original promise to begin with. So using this model, I think we can return to this automation backplane because we can isolate these sets of reactions, these sets of triggers, and associate them more closely with the services under their control. And it allows for, like I said, more complete lifecycle management. And interestingly, it allows for an immediate composable programming layer that can fit into our existing systems, right? We can build these bridges really simply between our automation systems that are controlled right now, usually by hand, right? And the streams of events that we already know are being logged or, in some sort of message-oriented middleware or what have you. So one question that comes up a lot is, well, how do I structure event data? And I want to bring everybody's attention to a project that just started this year. It's incubated by the CNCF. It's called Cloud Events. If you are really interested in what these big cloud providers are spending a lot of their time thinking about, one really fun thing to do is to jump on the Cloud Events calls. I think they're happening every, I want to say Thursday. At 1 p.m. Mountain, so I think 9 p.m. here. But if you hop on one of those calls, or if you hop into this project, what you'll see and hear are the major architects of these cloud providers debating what these data structures need to look like so that we have interoperability between clouds and so that we have an actual protocol to speak that is entirely event native. And so it's my hope that when the specification is finished, that the event-driven paradigm is going to become native inside these large commercial cloud providers. Here's hoping, at least. So let's finish up with some real-world examples. And the real-world example that I want to use comes to us from our friends over at Cloudflare. Now, Cloudflare, if you don't know, is a huge provider of DDoS protection, right, for websites. So it's imperative that Cloudflare can figure out the real-time state of what's happening on their network and react as quickly as possible. So the Cloudflare folks thought a lot about how to do this, and they chose an event-driven solution, and I want to walk you through what this looks like. So the first thing that they do is that they stream all of these log messages and they turn them into an event structure, right? So here's your log message. It originates from SNMP. Cool. This says an interface has gone down for some reason. Okay? In this example, which I will grant you is somewhat arbitrary, what the intention is to do is to say, okay, anytime we detect an interface going down that we didn't know about, we want to shut that port down administratively, right, so that we can keep these things in sync. So here is the structured event data that they end up sending across their message bus, all right? All they've really done is structured the data that's come from the log message into a data structure. And they've built this reactor. Now, I should point out that this reactor is a part of Salt, which is the automation engine that I build. But in Salt, we have this idea of a reactor, and the reactor is configured basically by saying, okay, anytime you hear an event on your message bus that matches this description, here are the things to do. Here are the states to execute, right? So this says, okay, if you match this, do these things, right? Here are the things that need to be done, right? We shut down an interface. Here's a little bit more about that. And also, we're going to send an email, right, so that people are notified that this has happened, right? But here we have a full automation lifecycle. We have a log message being emitted, and we instantly have automation coming in and reacting to that. If you want more details about how that stuff works, Mircea, who works at Cloudflare and designed this system, has a blog post on it. We'll put the slides up so that you can get to this later on. And of course, if you want more details about how we've implemented these ideas in Salt, and we're certainly not the only ones, but if you want to read about how we think about this stuff, we have documentation on that as well. And with that, thank you very much. I'll be around today if there are questions.